control to make some. Take your...
Not this time. No, not this time. It's totally made up. Pure fiction.
We're not talking about this or this. We're talking about this.
Welcome to Making the Space. My name is Pat Schuff. We will be talking about how to create education classes for a typical fabrication lab, which is one of the elements in a makerspace. I'm a member of TXRX in Houston, which is a fairly well-funded, fairly well-built makerspace lab. And one of the things they have is a fabrication room, which there's a picture of on the screen. And there are classes that you can take to learn how to make things with a 3D printer. TXRX has a very simple policy of the equipment is yours to use once you've been trained on it and know how to use it responsibly and safely. 3D printers, safety is not that much of an issue. Responsibility, that's a huge issue. Knowing how to use it without breaking the equipment, without ruining an extruder or the actual machine itself is important. In-person classes are the way it's done. For rural and remote labs, that's not always an option. If you're trying to build a makerspace in a smaller city, obviously the in-person class is the way to go. You can make revenue and help pay your instructors that way. But if you have to do it remotely and you're shipping your equipment to a remote site, like a STEM outreach program or something like that, video education is really the only way you can do it. And then you have somebody on site who's a mentor who helps people make sure the equipment works, make sure it's being used safely, and make sure that everybody's watched the training videos ahead of time. The first thing you'll need with a 3D printer is something to print. There are a variety of things you can print. Thingiverse is one of the locations that you can go to and look up a variety of things. The concept is you download an STL file. The STL file is then loaded into some software that generates code that is printable. So in this example, we're going to go through and look for something related to Settlers of Catan. The idea is it's a very simple thing to print. I can either print the base tiles, I can print characters that go into the system, or I can print a card tray holder, which is what we're going to be focusing on this time. So the card tray holder, you notice that you can print a single one, you can print multiples, you can print as many as you need, and they lock together. The whole premise behind it is this is a very simple design with a square flat plate and some corner edges that come up. So this should be a very simple first print. There's not a whole lot of complexity to it, and they can replicate each other. If they're done properly, they do lock together in that they can lock either going left and right or north and south. So they lock together in a grid to create card holders. I can use a variety of colors, and there are different ways of using them during gameplay, so it's a simple thing to start with. Once I've selected the design that I'd like to use, I go to the Download All Files, and it allows me to download the STL file. From here, I click Download, which takes me to the download folder. Once I have the file downloaded, I can open it, and if I don't have something associated with it, I can say Open With, and I want to use the Ultimaker Cura program, which will allow me to go in and slice it and generate G-code. When the Cura software uploads, you get a fairly nice image of what your print should look like. If I used a yellow filament, that's exactly what it would look like. I can use the up and down arrows to rotate it. I can use the left and right arrows to rotate it as well. I can use the plus to zoom in and see a little bit better image, or a minus to go out and see the whole scope. Now notice for this, I've got a MakerBot Replica Mini, which is a pretty small print plate. What I want to do is I want to use the Prusa i3 MK2, which gives me a much larger print plate because this is the printer we're going to generate the code for. From the Cura software, what I want to do now is generate from this STL file that we downloaded, we want to generate a G-code file. And by first selecting the printer, then we can say, go ahead and slice it. It's going to take about 2 hours to print this. It's going to use about 9 grams of filament. If I say save to disk, it's going to give me an ability to drop it into the folder. And we can say, yes, we want to save it as that file. And we can send this G-code to the Prusa printer, and it will print this one. So what we really want to do is optimize our print time. And I can come in here and select the item and say, I'd like to multiply the selected. I want to add 2 more copies, and that'll give us 3 copies. So we're going to print 3 at a time because 3 fit on the print bed fairly nicely. And with this, I can say, go ahead and slice it. Notice it's going to take about 5.5 hours to print 3 of these and use about 26 grams of filament. Say save to disk, and I can save it as I want 3 holders. And I'm going to give it a -A option because I've already saved it once. But from here, we can take this 3 holders G-code and send that to the printer. One thing that I typically do is once we've got the view, I can go in and look at it from an angle, click on the preview, and the preview will let us see, okay, there are 101 layers that are going to be printed for this, and we can scale back and look at how it's going to print or not going to print. Now, notice we get down to the bottom, all we see are the brims that are around the edge, and then the foundation, and then from the foundation, what we're looking for is any gaps or holes or arches or something that wouldn't print properly. And the idea is if I were printing between these 2 points and this was printed upside down, this would fail because we'd need a bridge support to support this brace right along here. As it is flat, we don't see any bridges or holes or anything that's going to cause any print problems. The final piece to get a 3D printer to work, to get it to start printing as expected, is we need to put a memory stick, which we've got a slight memory card. This is a small 8 gig memory card, but most computers don't have access to USB slot. So I had to go buy an adapter, and with this adapter you basically slide the memory card in, and when the memory card slides in, it appears as a drive, and it comes up as a removable drive. So now we're going to take this, and on this PC we will eject this, which will allow us to safely remove the USB card, and we're going to take it out. So this is what our card holder looks like when we try to print it. Notice it's relatively small. It's about the size of the cards that are in the card deck. In this example, I'm using red filament to print 1. And over here, I'm using a clear filament to print 3 at the same time. Now, it's kind of hard to see all 3 of them because they are kind of clear and they do show through the bed, but thought it'd be kind of interesting to see different ways of doing the print. The concept behind it is I get a memory stick, and the memory stick looks just like this, where I copy that from my computer, I slide it into the Prusa. Controls are relatively simple. I press the start here, and the first thing I have to do is preheat the extruder, and the extruder is right here. The idea is I put filament into this hole right here on the top, and it goes into this little metal roller that's inside that crevice, which then goes down into the heater, into the extruder, and it comes out the bottom where that nozzle is. There's some green on the bottom of that nozzle that got stuck in the previous print. Now, once I've got the preheat done, I can then go in and do the load filament. I take the roll of filament and put it up on top up here, and then feed the line down into the hole. When the filament is loaded, I then select print from SD card, and I can go in and select all of the different options. Notice this one is quantity 3, this one will be quantity 2, and this one will be the original one that we started with, so we can print that if we want to. There really isn't much else on here. It's other people's stuff because I'm in a common lab. Everything is shared, so what gets printed or copied onto the memory stick is usually left there. Now, the thing I like about this lab is it's quiet. It's relatively quiet. Notice that I've got multiple machines running, and there's not much motor noise. You know, we're right up against this motor right here. We're not hearing that motor down there make too much noise. We're not hearing this motor make too much noise. And the motor that's doing the bulk of the work, sliding back and forth, isn't making much noise either. So the MakerBot was pretty noisy. It would click and be pretty loud, but these machines are relatively quiet. You could use these in a classroom or in an office space if you needed to. Overall, this print job is going to take about 2 hours. This print job over here, that are printing 3 of them, is going to take about 6 hours. So I'm going to leave these and let them run for a while. It should build up pretty quickly, and we should be able to pick them up the next day from the lab, because it'll print overnight and I don't have to worry about it. So looking around the lab, some of the things that work and don't work, definitely you need a shelf. You have to have a policy of what to do when somebody's print is done. Do you peel it off and put it on a shelf? Do you leave it sitting on the printer and lock that printer up for hours until the person comes back? TXRX uses a shelf so that you move the finished print to the shelf, and then you store your spools in drawers. So under drawers that are well organized, and under drawers that are very random. The drawers cost about $150 to $200 each. So depending on how many users you have, how many spools are being stored, it could run into, $1,000 for 10 drawers, or for 5 drawers. The other option is some home-built things that look like shoe trees, where I can just rest them on dowels and make them available for people to grab and go. Some of the key questions that need to be asked when you're creating a 3D printer lab are, how are you going to lay out the printers? Are they going to be on a tabletop like we showed you with TXRX? Are they going to be stacked on metal shelves and bolted to the wall like a lot of the fabrication factories do? Basically you're going to need about 4 square foot per 3D printer, and then a volume depending on how tall the printers are, so you could probably stack 4 on a metal shelf. For the finished product, you need a standard bookshelf or some place to store it, and those are about $100 per shelf unit. Consider probably 1 or 2 should be enough, so you're looking at $200. Then you've got to ask, how many printers are you going to have operating? 1, 3, 35? It depends on what the purpose of the lab is. 1 is definitely not enough, and in my opinion 35 is definitely too much unless you're have a print factory. And then filament storage, that gets to be a real hairball. Under tabletop drawers cost about $150 for a 2-drawer set. And if the drawers are too deep, it becomes just a jumble of spools. If they're shallow enough, like the metal ones that I showed, where it only stacks one deep spool, so you can't really stack on top of. Other options are homegrown type things that provide a shoe tree, a wooden dowel that will rest the spools on, or a hanging closet rod with a hook that comes down and hooks the spool on a curtain rod or a closet rod. Any of these work, and that's one of the basic questions you need to ask, is what works for your lab. And that's my open question for the comments is, if you're a member of a lab, how do you store filament? Because I don't think TXRX does it properly. How do you deal with finished print shelf items? Do you lock up the printer until the person comes back, or let the next person peel it up and put it on the shelf for them? And then How many printers do you have? Do you think it's enough? Do you think it's not enough? Do you think 3's enough? Do you think 10's too much? Do you think 10's not enough? Leave comments below and let me know your opinion.
Hey, bro. How we doing, man? It's been a while, man. That's so rad. This one's my favorite, man. Don't you love it? Yeah. Oh, man, you want a beer? Alright. Oh, man, yeah, bro. This is the best. I'm so glad we're all back together and stuff. It's great, man. Yeah. Hey, did you know about the party after the show? Oh, man, it's gonna be the best. I'm so stoked. Take it easy, bro.
Now back to your regularly scheduled program.
And while some may see them as the crazy ones, we see genius. Because the people who are crazy enough to think they can change the world are the ones who do.